Chemistry is the study of matter, how it reacts and how we can control those reactions. Some chemists specialise in the theory of chemistry, some in the chemical reactions of nature, while others focus on making compounds. And we call those chemists synthetic chemists. And they certainly touch our lives in many ways, from the polymers in your clothes, to the medicines that you take, to the ink in your pen. Synthetic chemists design and carry out reactions to make the compounds that surround you. However, making a compound is only one part of their job. The challenge facing chemists is often not making the compound, it's isolating it. When we carry out a chemical reaction, it's incredibly rare to have only one product left at the end of it. There's usually at least one other product that we're not interested in, or some of the reactants are left over, or the product is mixed with the solution that we carried the reaction out in. Either way, what we're left with is a mixture, and the job of the chemist is to extract the compounds that we want from the mixture of chemicals that surround them. Welcome to the study of mixtures and separation techniques. In this first video, I'm going to look at the type of mixtures that we'll encounter at GCSE level, and I'll give you an overview of the techniques that we have at our disposal to separate them. I'll start with the problem, the range of mixtures that we face, and then I'll give you an overview of some of the ways we use to separate them. What follows is by no means an exhaustive list of the ways that substances can be mixed together, but it does cover some of the simple ones that you will meet at GCSE. We'll start with solids. We can have mixtures that are relatively easy to spot, such as mixing this sand with this salt. This is something we call a heterogeneous mixture, and it means that the chemicals are physically separate from each other. You might need to look under a microscope to spot them, but they are distinct, such as the sand grains and salt crystals here. You can also get homogeneous mixtures. These are harder to spot because the substances are mixed at an atomic level. But they are still mixtures because no electrons have been transferred and no bonds are formed. Chances are there's a homogeneous mixture right next to you as you watch this video. The best examples of them being things like alloys such as steel or brass, maybe a bit of gold jewellery, because even 18-karat gold is actually a mixture of at least silver, copper and gold, possibly with a bit of zinc in there as well. Mixtures of solids might be the easiest to understand and visualise, but they're actually often the hardest to separate, and we usually need to melt or dissolve at least one of their components to split them apart. We'll come back to that example in a few minutes' time. Next, we'll look at examples where we have a mixture of a solid in a liquid. Now, as long as the solid hasn't dissolved, it represents another heterogeneous mixture. And these are probably the easiest of all to separate. In fact, you do this every time you drain the water from your pasta when you're making dinner. It's really a process we call filtration, and all that changes is the size of the hole that we let the water pass through. Separating sand from water requires sheets of filter paper, and this is the usual example given for this technique at GCSE. There's a video on filtration coming out next on this channel. But what about homogeneous mixtures. Here, the solid has completely dissolved in the mixture, down to the level of its individual particles. And here, we often use another word for these mixtures. We call them solutions. When we talk about solutions, we talk about them in two parts. First of all, a liquid that does the dissolving, that we call the solvent, and the thing or things that get dissolved, which we call the solute. Perhaps the most obvious example here is salty water, but there are loads of examples around you, from your favourite flavoured drink to the blood plasma flowing through your veins. All of these are examples of aqueous solutions, where water is the solvent. But do remember that any liquid can be a solvent. If we add gases into our mixtures, we get several more options. We could have a homogeneous mixture of different gases, such as the air that we breathe. But there are a whole range of options here, such as these. So, you've seen the extent of the problem. As chemists, we have to be able to separate all of these mixtures into their individual components, and some of them can actually be really tricky to split apart. I'm going to focus on those that you will meet at GCSE in the UK, and they are quite straightforward. Now, I'm only going to give you an overview here, as there'll be separate videos looking at the practical details of each technique elsewhere on the channel. We'll start with the one we've already mentioned, filtration. An insoluble solid in a liquid. And all that we require here is a piece of filter paper with a suitable size pore and enough time for the liquid to drain through. But what about a homogeneous mixture, where the solid has dissolved into the liquid? Here, it all depends on whether you want the liquid, the solid, or both. To retrieve the solid only, we simply evaporate the liquid away, often with the help of a little extra heat. If this is carefully managed towards the end of the evaporation process, elegant crystals of the solid may form, and we call this process crystallization. If we want to retain the liquid, then we must capture the evaporating gas and condense it back into a liquid. And we call this process distillation. So far, we've only been splitting up two different components, but sometimes it is more complicated than that, where there could be several different dissolved substances in our mixture. To be able to split up such complex solutions, we require techniques such as fractional distillation or chromatography. If we have a mixture of multiple different liquids, we could use column chromatography or high-performance liquid chromatography, but in most cases it'll be much more cost-efficient and therefore a better choice if we could use fractional distillation. This is the technique used all over the world to separate the different fractions of hydrocarbons from the complex mixture that is crude oil. We can actually use the same idea to separate mixtures of gases. First, we cool and compress the mixture until all fractions turn into a liquid, and then we gradually evaporate them off again by reducing the pressure and increasing the temperature, collecting each one in turn. It's a high-tech process, but we do this every day to get the oxygen that we use in hospitals, liquid nitrogen for use as a coolant, and argon for welding, lighting, and the handling of very reactive materials. So, now you know your options. The fun part for chemists is problem solving, which techniques to use and in what order to separate a complex mixture. I'll finish with a quick demonstration. Let's go back to that salt and sand combination, because this is that heterogeneous solids mixture. And I could spend all day manually going through this and pulling out the salt crystals with a pair of tweezers. Fortunately, there is a much easier solution. All I need to do is add water. Now I have a homogeneous mixture of salt and water and a heterogeneous mixture of salty water and sand. First, let's get rid of the sand. Filtration is the obvious choice here. I'm just going to add a little extra water to my sand to make sure any remaining salt is dissolved away, and then I'll set it aside to dry. So I now have my salty water and my sand. And as I don't need the water back, I'm simply going to warm it up . And then I'm going to allow the last little bit of it to evaporate at room temperature. And here are my grains of sand and my beautiful salt crystals, perfectly separated. A chemical problem solved. So, you should now be able to give examples of heterogeneous and homogeneous mixtures. You should be able to understand the options that you have available to separate them, and you should be able to give a few examples of when they are used. We haven't touched on the technical details of carrying out these procedures yet, but that is what we'll be covering in the next few videos. If you're trying to remember the key points or are revising for an exam, then the worksheet on my Patreon page is free and it's there to help you. There's a link in the description below. Happy studying and see you next time.